first of all, thank you everybody for having me. I'm really excited to present what I've been working on for the past year and a half to you guys. And the thing about bird research, as some of you may know, is when you talk about it, it's really exciting to you, but sometimes the people that you're speaking to kind of stare back with blank faces. So I'm so excited to be talking to people who understand what I'm saying when I say that it's important that we care about the birds. So I'm so excited to be here. And like Nancy said, my research is on the impacts of the Sightsee Dam on bank swallows. And I had a whole intro, but I sent Nancy my slideshow early, and then she stole my intro. So I'll keep it brief. But as she said, I'm a member of the Beak Lab at Thompson Rivers University. I'm in the second year of my master's. And yeah, it's been awesome. I also did undergrad research in the Beak Lab a few years back. And Nancy actually was my supervisor. I don't know if she remembers, but she was my undergraduate supervisor, and I'm very happy that she invited me back to talk at the Naturalist Club. So yeah, very excited to be here. So I assumed that no one would want to hear me talk the whole time. So I watched Ollie's presentation from a few months ago, and he did some trivia with you guys. And I thought that was super fun. So I thought we could do some trivia. And since my project is on dams and it's on bank swallows, that's kind of the theme of the trivia. So not trivia you would find at the bar in Kamloops, it's niche. So I'm gonna put, it's just for fun, it's just silly, so I'm just gonna put the question up on the board. And if you guys know the answer, just shout it out, and then I'll put the answer up. And yeah, it'll just give us a little bit of background info about both of the topics. So this is the first question. How many dams does BC Hydro maintain? 50? 10? 30? 82, which was shocking to me. But they're not all the very big earth-fill dams. Some of them are much smaller. Okay, next question. 80% of BC Hydro's power come from which two rivers in BC?
Peace River.
The Peace? Columbia. Yeah, and the Columbia. You guys are right. I thought it was the Fraser for some reason for a long time, but the Peace and the Columbia. Okay, what are two leading causes for aerial insectivore decline?
Habitat destruction.
Yeah, you guys nailed it. The first three. So habitat loss, prey decline, and prey decline because of pesticide use are the reason for aerial insectivore decline. Okay, where do bank swallows spend their non-breeding season? So our winter, where do they go?
They bury themselves in the bottom of marshes. People used to think.
I think I heard someone say South America. Yeah, so South America, the Chile is where the eastern bank swallows go, but we're not exactly sure where the western bank swallows go, but we think similar places. Yeah, they're very long distant migrants for such small birds. Okay, we got 4 more. What kind of nesters are bank swallows? Yeah, someone said bank. Yeah, basically. They're burrowing colonial nesters. Okay, what's the old world term for bank swallow? So what are they also known as? They have another name. Yeah. Yep, they're known as the sand martin. Oh. Okay. And how many nests can be found in a bank swallow colony?
500.
Okay, you're all right. 2 to 2,000. 2,000 is massive. I haven't seen any that big, but apparently that's as big as they can get.
What's the most you've seen?
I've seen a couple hundred when I was on the piece. Okay, and this was the best fun fact that I found. In 2023, how many workers were on site building Site C?
15,000.
Okay, not quite that high.
You got to include consultants.
Yeah.
laborers.
Yeah, about over 5,000 per month, which is huge to me. I mean, that's the power of teamwork. Is really, it's incredible how many people are on that site. So yeah, you guys did awesome. You answered the questions so well. I thought I was gonna stump you, but great. All right. So I'm gonna get into it. I'm gonna start broad, and then we'll kind of get into my research as we go on here. So I'm gonna start with a figure here that maybe some of you have seen before on the right. This is from a Birds Canada report. And this is on population trends of different groups of birds in Canada since 1970. So you can see that about half of these groups of birds have had a very large decline since they've started monitoring them. And the report states that 168 species in Canada have decreased in population since 1970, which isn't great. I did want to include the good news though. So 143 species have increased in population since 1970. So that's good. The water birds and the birds of prey are still doing awesome. But the bird that I study is the bank swallow, and that's an aerial insectivore. And aerial insectivores have declined by 43% in the past about 50 years, which is concerning. And as we talked about a little bit in the trivia, there's different reasons for why these birds are declining, but from the research that's been done, the main reasons for this are habitat loss, habitat degradation, and then climate change, of course, and loss of insects is another very large one, which is interesting. Aerial insectivores primarily feed on flying insects, so when they lose their prey, or when they lose the insects, they lose their food source. So that's concerning. Now, bank swallows, they're a threatened species in Canada under the Species at Risk Act. And so aerial insectivores, they've declined by 43%. Within that, bank swallows have declined by 98% in the past 50 years in North America, which is a very concerning statistic. And bank swallows, they feed on aquatic emergent insects. So these are insects that they lay their eggs and live their juvenile stages in the water. And then as adults, they grow wings and they fly out of the water, and then that's what the bank swallows feed on. So kind of a specific type of insect is their preferred food source, and that's important for my research. Okay, so now I want to switch gears a little bit and talk about hydropower, because my study is on a specific dam. And I think it's good to know a little bit of the background of hydropower in BC leading up to that. So as I'm sure lots of us know, BC runs on hydro, and hydro is a renewable energy source, which is good. But that also comes with some caveats. Now, hydropower, I didn't know this coming into this project, but BC primarily runs on earth-filled dams, and the majority of the earth-filled dams in BC were built between the 1960s and the 1980s, and that's what we use for our hydro. So an example of that is the earth-filled dam, the John Hart Dam in Kamloops River is the top picture there. And then I also just included a picture of a run of river dam on the bottom there, which BC has about 60 of these. So the first trivia question I had was the number of dams. 60 of the about 80 are run of river, so they're much smaller than the earth-filled dams. The run-of-river dams are typically downstream of the earth-filled dams, and they're much smaller, much less invasive, but they also contribute much less energy to the grid. So after the 60s and 70s, when we had this big this big boom of hydroelectric dams being built, nothing else was really built in the province for a long time. And instead, BC Hydro decided to upgrade and refit the aging dams as time went on. So that's what happened at the Lower Bonington Dam in that top right picture there. They upgraded it really recently. I also know that the John Hart Dam in Campbell River is currently going through upgrades to match the increased energy needs in the province. And that's where Site C comes in. So just raise of hands, who here has heard of the Site C project? Okay, most of us. That's good. We're an environmental group, so I assume so. So something I recently learned was Site C was actually proposed in the 80s when they were building all of these other dams, but it was denied because of environmental reasons. But then in 2011, it was brought back on the table and it was approved. I don't know why that happened, but it was. And they began construction in early 2016. So just for anyone, if there is anyone in the room unfamiliar with the project, the Site C Dam is a dam that's being built in northeastern British Columbia along the Peace River near Fort St. John, and it's been under construction for about 10 years. So I think I would be remiss if I did this presentation without mentioning the public opposition of the dam, and I'm sure many of us are very aware of this. A lot of groups were highly opposed to the dam for a lot of reasons, and a lot of valid reasons. I'll just name a couple. You do a quick Google search and you'll find hundreds of articles like the 3 I put on the screen, but I know the NDP Party of Canada for several years publicly opposed the dam for environmental reasons, for budget reasons, and because they thought that the extra power was just not necessary. Many, many environmental groups also opposed the dams for similar reasons. And the West Moberly First Nations and the Treaty 8 First Nations were opposed to the dam since its conception, since it was brought to the table, because it infringes on their treaty rights. But unfortunately, in my opinion, the dam did go through. I'm not any pillar of morality to say whether the dam should have or should not have happened, but the facts are is that it happened. It's been built for the past 10 years, and in 2025, it has just now come to completion. So now there are consequences because of that. So here are just a few. One kind of specific to the Peace region, one consequence of the damming is that it's destroying some of Canada's rich agricultural land. Of course, it's a dam, so it's impacting fish and fish habitat. It also impacts culturally important plants, and it's a barrier to culturally important wildlife and wildlife movement. And it's also damaging habitat for, the numbers I found when I was doing my research was at least 63 endangered, red-listed, blue-listed, at-risk, threatened, or special concern species. So my research is on one of these 63 species that is being affected by this. So my research, of course, is just a drop in the bucket of the work that's being done, or a drop in the reservoir, if you will. But there is a lot of research and there's lots of monitoring going on to see how these species are being affected by the dam construction. So yeah, kind of self-explanatory. That's what I'm doing. I'm spending 2 years studying the impact of the Site C Dam on construction, Site C Dam construction on bank swallows. So as we mentioned, bank swallows nest in eroding banks along rivers, and that's exactly what all of the bank swallows we found along the Peace River did. So the largest population of bank swallows in British Columbia that we know of is along the Peace, where the dam's being constructed. Upstream and downstream, they're both present. And I just have 2 quick clips that I'm gonna play that might show you just how many there are. So that's one colony that we found. And this is another. It's a little hard to see because it was a wildfire year, but some of the colonies you would see hundreds of birds flying right over the river, very, very close to the dam construction. So, of course, this is a master's thesis, so we have kind of some specific questions that we're asking in this context, and I'll read them to you guys. So the first is, are bank swallows along the Peace River exposed to harmful concentrations of trace elements, including heavy metals, due to the dam construction? And the second question is, what are the sources of diet for site sea bank swallows? Does this indicate a loss of prey in the habitat? So as I mentioned at the beginning, loss of prey is one of the reasons cited for bank swallow decline. So if we find that these bank swallows are not feeding on their preferred prey, that could have some really detrimental impacts on the population here. Yeah, so I'm gonna do a little bit of background into the questions. So first, I'm gonna talk about trace elements and heavy metals. These are kind of vague terms, but, and they encompass a lot of things. So I'll start with trace elements. So trace elements are naturally occurring and necessary for organism functions. So think like zinc, iron, magnesium, manganese. These, I mean, we need these as well to an extent, and they're naturally present in the environment. But if the concentration of these elements in an environment reach such a high level, there's a threshold where they then become harmful to the wildlife in the environment. And there's also the possibility for heavy metals to be introduced into the environment. And these serve no biological role, and even at small amounts, heavy metals can be very harmful to wildlife. So think lead, think mercury, cadmium, arsenic, chromium. These are heavy metals that can be introduced from large sites that even at a small amount can be really harmful to the wildlife. And there's a couple of different mechanisms of how these trace elements and heavy metals can enter an environment. One mechanism that we think is likely is metal leaching. Metal leaching, you might think of mining. It's more associated with mining, but essentially it's when you crush rock, there are chemical reactions that occur, and metals can be leached into the environment. It's also called acid rock drainage. And in 2018, Site C was charged with failure to report over 3 million liters of potentially contaminated acid rock drainage water into the Peace River. So we know that it happened, and we know that this was probably not an isolated case. There's also other elements like mercury that can just naturally become elevated in areas with extensive water management, like reservoirs. This is well known. And it's because of the microbial processes that convert inorganic mercury that is otherwise trapped in the sediment to become bioavailable methyl mercury, and it then is able to bioaccumulate up the food web. And the third reason is just general construction activities. There's lots of studies that say that construction sites are known to have heavy metals in their dust, especially construction sites that have a lot of cement or a lot of welding. And I'll just point you back to this picture of the dam being constructed. Can probably assume that there's some of that going on in a site like this. Okay, and now I'm gonna move on to my question 2, which is the diet. And I'm gonna explain the rationale a little bit more because sometimes it cannot be super clear. So the dam is of course altering the landscape of the Peace River pretty drastically. And one thing that it's doing is reducing low-lying wetland habitat. And these habitats are essential for the aquatic emergent insects. So if we lose these insects because of loss of habitat, then that means that the bank swallows are losing their prey. And as I said before, bank swallows really prefer aquatic emergent insects because aquatic ecosystems have essential fatty acids that are important for bank swallow brain function, cardiovascular health, growth, reproduction, and immune responses. So you can say, well, maybe the bank swallows can feed on other insects from terrestrial ecosystems, and they can, but they don't necessarily have the very high quality fatty acids in those insects that are going to be great for bank swallow health, reproduction, and growth. So they'll be less healthy. So those are my questions, and I'm going to show you guys a few pictures from our field work. So the field, to answer our questions, we had to collect samples of the bank swallows, and we did this in 2021 and 2023. I say we because I was not there in 2021 collecting samples. Environment Canada was, and I took their samples. And then I went back in 2023 with them to collect the 2023 samples. So the first thing we did was we boated up and down the Peace, upstream and downstream of the dam construction, to find our colonies. Now, bank swallows, they do return to the same area year after year to breed, but they don't necessarily return to exactly the same place, the exact same colony that they were at last year. Especially in this area, BC Hydro had been netting some colonies off, so the bank swallows couldn't return. The habitat was changing a lot over the years, so even though we were there in 2021, we still had to go re-find the colonies in 2023. And what we did is we set up mist nets in front of the colonies, you can see at the bottom, and the birds would just fly out of their burrows into our nets. We would only keep them up for about 15 minutes at a time. And then we would collect our banding data, age data, sex data, and we would also collect 2 feathers and a very, very small blood sample from each bird so that we could answer our chemical questions. And then the best part was our boat driver, Jason, every single time would release the birds. And there's a picture or a video of that. And I have just a few more pictures. So on the left is another picture of us collecting our birds from the mist nets. The middle picture is a juvenile bank swallow, and you can tell from the gape on its beak, so the little yellow part on the beak. And then the far right is us setting up a mist net actually from the top of a bank. Some of the banks were kind of hard to access. Some of them were much higher than we thought they would be, so we couldn't reach them from the ground. So sometimes we had to go from the top and get a little bit creative with it. And then after I collected my data was the very, very fun part, which was all of my lab analyses. I forgot I had this. This is a map of all of our sites that we visited. So the top one is 2021, and they visited sites close to the dam, both upstream and downstream, and then far from the dam, both upstream and downstream. And then the second map is from the year that I went. And we still collected a lot of data, but not as much as we could in 2021. You'll notice particularly upstream of that, so the black dot is Site C. Directly upstream, we had a hard time collecting data, and that's because construction was just so far along. We couldn't access a lot of areas, and a lot of areas of where the bank swallows used to nest were netted off, so they couldn't return. So it was harder to collect data upstream in 2023. And then now we got to the lab analysis. So I won't dwell on this, even though it was very fun to do, but the first analysis I did was actually in London, Ontario, at Western University, where we did a fatty acid analysis. And this was to answer my first question, or my second question, what are the sources of diet? So essentially, all of these little test tubes are blood plasma, essentially, and it was able to tell us what fatty acids were present in the blood of the birds. And then the second analysis I did was a heavy metal analysis of the feathers, and this was to answer the question, are bank swallows along the Peace exposed to harmful concentrations of heavy metals? I did this at TRU. This was so fun because we digested the feathers. So again, they're test tubes, but each test tube is digested, so like a chemically melted feather. And we were able to run them through instrumentation and see what heavy metals were present in each feather, which was super cool.
So what was your results on
Oh, I'm getting there. So my results, I'm gonna start with kind of a large figure, which is a lot to interpret. So this is average accumulation of each of the 20 elements that we tested for each feather, so for each bird. So broad conclusions: are there trace metals, are there heavy metals in the environment surrounding Site C? Yes, there are. But you'll notice that there's some really broad ranges for some of these metals. Like if you look at, I don't know if there's a thing. If you look at, for example, chromium or lead, those are two harmful heavy metals, but there's a very wide range of the concentration that's found. And what was interesting is we found that different birds at different sites accumulated really different concentrations of the metals. So, for example, upstream Site C, where they're building the reservoir, there were very high concentrations of chromium, lead, aluminum, copper, and nickel compared to the birds that were nesting downstream. So the birds nesting downstream had much lower concentrations of these heavy metals. But the birds nesting downstream had much higher concentrations of mercury, cadmium, and arsenic than the birds nesting upstream. So arguably it's all bad. I don't really know if anyone's winning in this situation, because if you're not accumulating high amounts of lead, well, then you're downstream accumulating high amounts of cadmium and mercury and arsenic. So, you know, it's, yeah, yeah, stay on vacation. So that was one result that we found was, yes, there's spatial differences. Birds nesting in different areas are accumulating different concentration of these harmful metals. But is anyone really safe from accumulating the heavy metals? Not really. They're all being impacted in some way. What we did find was the trace elements that I mentioned before that are only harmful when they reach a certain threshold, we don't think they reach that threshold. So so that's okay, but these really harmful heavy metals are accumulating in the population. And what does that mean for the birds? It's not awesome. So lead, cadmium, chromium, and mercury are known to induce organ damage, even at low levels of exposure. Mercury and cadmium are known to affect reproductive success, overall health of the birds. Cadmium can suppress egg production, impair growth, cause mortality in wildlife, even at low levels. And lead is known to impair the immune system, the nervous system, the reproductive systems, and cause neurological damage. So these are elements that are all present in the system and may be having these impacts on the birds. Lastly, I'm going to briefly touch on the diet results. And I'm just going to show you two figures from my diet results because it gets a little muddy when I bring them all up. But if you remember from my previous slides, I said that there are certain fatty acids that are only present in aquatic ecosystems, and they are important for the health of the birds. So two of those fatty acids are DHA and ARA. So this graph is DHA, the graph on the right is ARA. And what you'll notice is the yellow bars represent the juvenile birds, and the blue bars represent the adults. So the juvenile birds near Site C and far from Site C have much, much higher levels of these essential fatty acids than the adults. So the juvenile birds are still being fed a relatively healthy diet, and the adults are probably eating a diet that's mixed, half terrestrial, half aquatic based. And this is not really surprising. It's not surprising that the birds are feeding their young the higher quality prey. But what's an interesting part of this study is the higher quality prey are aquatic, which means they are probably also have higher concentrations of heavy metals. So you can't win, exactly. Unfortunately, we are not able to tell what the heavy metal accumulation is between adults and juveniles. We can't separate that out in my study. So that's one piece that's missing, but we are inferring that the juvenile birds are eating a diet that's, although it's higher quality, it's also likely higher in their heavy metal concentrations. Yeah, and that's basically, sorry, what I just said. So this is important because food quality is known to have a greater impact on overall health and survival than food quantity. So if the adult birds are eating a terrestrial-based diet, they could still be eating a lot of prey, but it's still not as nutritious as the aquatic-based prey that they want. All right, so that's about where I'm at with my research. I have no idea how I'm doing for time. I'm sorry if I'm too late or too fast. Okay, so kind of just some general conclusions from what we've found so far. So yes, we have found evidence that the Site C dam is altering the environment in a way that is likely negatively impacting the bank swallow health and reproduction. However, I'm doing a short-term study, so it's really hard to tell exactly what's going on. But luckily, my study is part of a 10-year-long study that is being conducted by Environment Canada. So, time will tell what the further impact is on these birds. There's also a tracking study, so we'll see if they'll even return to the piece. There's a lot unknown right now, but these are kind of the general conclusions that we're drawing so far. And in general, continued monitoring of populations and environmental studies are essential for informing conservation strategies and mitigating potential threats to bank swallows and other aerial insectivores. And I'm sure you guys are all very involved in eBird, but I know Birds Canada does a lot of long-term data studies on aerial insectivores. There's ways you can contribute to the eBird data if you're interested. But yeah, it'll take a few years to really understand what's going on with these bank swallows in the Peace region. And for me, like Nancy said, I'm almost done my master's. I just have to finish my thesis, so I have been and will continue to be like Kermit the Frog here, writing up my chapters, and hopefully finishing sometime this summer. And thank you.